In this video we will learn about false discovery rate, and also we are going to first understand what is false discovery rate. Then we will discuss why this false discovery rate is very important when a large number of tests are conducted, and what is the relationship between the p-value and this false discovery rate. Okay, so in generally, what is false discovery rate? So when we conduct experiments, we know that we initially set null hypothesis and alternative hypothesis. So the null hypothesis states that there is no difference between the means of the two groups. Okay, so when p value less than 0.5, so when the mean values are different between the two groups, and we say from that, or we make a statement from that, okay, the observed difference between the two groups by a random or by chance is very less. So when we say it's less than 0.05, suppose we say 0.03 or 0.02, so the p-value, we say that the observed difference between the two groups comes by a chance of just 2%. That means when we conduct 100 times a test, so we may get a mean value difference between the two groups by chance only 2 times, and remaining 98 times the difference comes by the internal factor or the biological factor only. Okay, so when we do such experiments, when we do only one test, okay, we rely on p-value. But when we conduct multiple tests, for example, when we observe the difference of gene expression between the two samples, if each sample contains 10,000 genes, that means we do the t-tests 10,000 times. So when multiple t-tests we perform between the two samples, so there may be a possibility that no false positives coming in these p-values. What are these false positives means? So though there is a no generally, so we in null hypothesis we state that there is no difference between there is no difference between the two groups. Okay, so but sometimes we get a difference, okay, between the two groups, and when that difference is less than 0.05, we simply state that no, that is coming that difference by by chance is very less. Okay, so it is a by chance the such difference coming, the coming of the difference is very less. We generally we make such a statement. Okay, when we take such a 10,000 tests, so there may be a chance that no, sometimes the difference between these two means with the p-value less than 0.05 is also sometimes come by chance. So that means when we take 10,000, maybe out of this 10,000, maybe some 100 or 200 significant differences, p-value less than 0.05. So such differences between the two groups by a chance, when we say when we say that no, by chance such difference is very less, and when we say alternative hypothesis is correct, so in such a condition, when we see that no, at least a few significant values which may come by just a chance again. So this is calculated by how this is calculated by false discovery rate, how many significant values which are false positives. False positive means generally there is no difference between the mean values, but by chance these samples they got the mean difference, okay, by chance. So how we calculate FDR is by dividing total false positives with the total significant results. Suppose when we perform t-tests, suppose 100 t-tests, if we perform 100 t-tests, and if 5 false positives are there, so we divide that 5 by 100 and we calculate the false discovery rate. And first of all, we have to understand how we find out the false positives. So to find out the false positives, so there is one method that is called BH method is used to calculate these false positives. So how these positives are calculated? So initially uh, we we rank the significant values. Suppose when we perform 100 t tests for 100 genes between two samples, so all the p values are initially which are less than 0.05, all these are ranked based on their they're ranked in a ascending order. So all these are arranged in ascending order and will be given ranks like serial number, like in a serial number like 1 2 3 4 like that. Okay, after giving the ranks, so this this critical value for this is calculated by dividing its rank position by the total significant values into 0.05. Suppose see when we take third significant value, that means the significant value which is in the at number 3 position, so we divide that by 3 by total significant values 100 into 0.05, and we calculate the its false positive value, or we can calculate we calculate its critical value. So we get all the critical values for it. So when the critical value is less than 0.05, when the critical value is less than 0.05, so those are called completely positive values. So values which are more than 0.05, critical values which are more than 0.05 are considered as false positives. Suppose 100 tests, if we perform 100 tests, maybe 90 significant the critical values for 90 significant values may come less than 0.05 and 10 may come more than 0.05, so those 10 are categorized or grouped as false positives. So when we have this, so we find out the false discovery rate by taking this 10 by total significant values 100. So when we divide 10 by 100, so we get exactly that 10 by 100 which is we get the false discovery rate. So this is how we calculate the false discovery rate, and also we calculate critical value for each p value when multiple t tests are performed. So this is about the false discovery rate. Thank you so much.